Hello, everyone. Hopefully you can all hear me today. Feel free to use the chat box if you have questions, comments, concerns. I like to try to make all my presentations as interactive as possible. So if you can hear me, just go ahead and type in "yes, I can" into the chat box. Perfect. So today we're talking about cloud computing. We're going to touch on Google Compute and a little bit of Google domains and servers as well. The point of today's webinar will get you at least understanding what essentially is cloud computing and what can we do with the Google Cloud Compute engine. I'm going to try not to use too much technical jargon with you today, just so everyone can have an easy way to learn. So when we talk about cloud computing, this idea of cloud computing has been around for years. And everyone sometimes will picture, satellites or something like that off into the sky. But that's not entirely the case. When we say cloud computing, we're actually picturing something more like this. So the idea of cloud computing essentially is the practice of storing your data, sometimes your network as well, somewhere else where you don't have to manage it. So if we think back in 20 years ago, we used to have servers in our closets and our workplaces that stored all these files, information, even our email handling. And now we mostly move emails, for instance, off into the cloud, somewhere else for someone else to manage. Basically storing this data so it's not on something local or a personal computer. What's really cool about having it somewhere else is that you don't have to manage it. It's usually managed by someone else at a data center. So think of the best way to think of it as, instead of walking down a hallway where you can access your data center via the internet or the cloud. So instead of walking down a hallway to look into your server closet, you have to log into some sort of portal and then you can see your computers. In a perfect data center, this is essentially what it would look like. Just rows and rows and rows of servers, hardware, equipment, usually with multiple layers of redundancy. And that's really important if you have data that's sensitive and you don't want to lose it. One of the perks of using a cloud computing or cloud computer service is that you don't have to worry about all that. So if you were hosting files, for instance, in your office environment, you'd have to worry about fires. You have to worry about disasters, the building falling down, making sure you always have power or redundant power, making sure you don't get impacted by a tornado or a hurricane. Whereas when it's in a data center, they usually, or they should, have all these safeguards in place where they'll help mitigate that risk. So there are some pros and cons with cloud computing. The obvious pro is somebody else has to manage it. And by managing it, they make sure it's always up. There's redundancy, there's power, and usually security. And I asterisk the word security because, so let's say I'm worried about Big Brother looking at or asking for data records. So let's say I'm hosting my files at Rackspace or Google Cloud, and the government comes knocking and they say, hey, I want to see all of Brian's servers. Now, they may or may not have your best interest in mind when they release the keys or don't release the keys to your servers and your equipment. So you have less control over that when you use cloud computing, whereas if it was inside your own data cabinet, you can at least call up your lawyer, whatever it may need to monitor and protect that. The other pro with cloud computing is accessible anywhere in the world with an internet connection. So if we were thinking of back in the office when we didn't have VPNs, for instance, and you wanted to access your files, but you already got home, it's too late. You have to go all the way back to the office to access those things. With Google or with cloud computing, however, that changes. You can go anywhere in the world and have access. And another nice perk of cloud computing, it's really low barriers to entry. It's very inexpensive to start having a server because you would pay like a prorated rate to run the server. So to put it in different terms, a server would normally cost, if you wanted something that was beefy enough to manage your files, your emails, and a website or two, you're looking at about $10,000 for a decent sized server. Most people, if you're starting a business, don't have extra capital like that, 10 grand, lying around to not only buy the server and set up the server, get all the things configured, It's a pretty big pocket punch. So what people like to do with cloud computing is that it's easier to scale. So I can get a cheap server, pay only a few bucks a month, and then as I need more resources, I can add those resources virtually through a cloud computing engine, which then helps me save more money. So if I were growing my business and I realized I needed a second server, or the server I bought wasn't good enough, you can't necessarily return that server and get all your money back. But with cloud computing, you would just swap out for a different configuration, and then you would just pay the difference in increase of cost or resources that you're buying, such as RAM or memory. The cons, however, are that your infrastructure is determined entirely up to the vendor. So let's say you love Dell, you're a hardcore Dell fanboy. You can't necessarily tell Google or another cloud computing provider saying, hey, don't give me any of those HPs. I really like Dell. They pick the infrastructure. They choose what networking equipment to use. They will choose what type of server manufacturers, and usually parts and pieces of those components are all up to them to decide. Your only decision point is how much RAM, how much space, and how many processors would you like, and the processing power of those processors. Outside of that, they get to pick all the other pieces, such as manufacturer models, etc. The other thing about cloud computing that's considered a con is, let's say your internet goes down at your workplace and you have all your files located in the cloud. Without the internet, you're not going to be able to access your files because there's no connection to it. But the reverse is also true, because now you can then go home and access all your files. So you can kind of mitigate some of that risk with a little bit of flexibility of how you connect to the internet. So it doesn't necessarily mean you have to be in the office now. If power goes out, internet goes out, you can go anywhere else you'd like to access your file servers, etc. There's a few different cost-saving factors involved with having it in the cloud or being on premise. So if I were to break down like data security cost, maintenance, agility, mobility, this is the chart for you. So with the cloud, you decrease the dangers of a data breach. You can never fully remove yourself from getting breached. Cloud vendors get hacked all the time, but you help decrease that. It's unlikely that you have a team of security engineers at your beck and call, especially if you're a smaller business, monitoring all your data, making sure things are safe, watching for intrusions and things like that. By using the cloud, part of your monthly fee to utilize said service is they provide that security package around for you, because obviously if they get hacked, a lot of their other clients also get hacked. So they have a whole team in place with all sorts of rules and responsibilities and policies to help protect your data, as well as the data of the other clients. We already touched on this with cost. You definitely have decreased costs when you're starting off with using cloud computers, because you don't have to purchase an actual whole server. You just lease one essentially, or you're renting the capabilities of said server. Whereas if you're doing everything on premise, you have to buy that equipment right out of the start. You can't buy it in chunks unless you had like a no interest credit card or something along those lines. Maintenance with the cloud computers, you don't necessarily have to have dedicated IT staff monitoring that equipment, because again, you're paying for this service. Somebody else will be monitoring, making sure that the servers are updated, making sure they're running, doing patches as needed. But with on-premise, that's entirely on you or your IT team to make sure that those things are being taken care of. So if you don't have a huge IT background, it's very beneficial to leverage a cloud computing company to manage all that for you. In terms of speed or agility, with the cloud, this third party does all your updates and product enhancements on a regular basis. If you're doing something on premise, you're usually limited to the solutions at the time of purchase, unless if you paid for the continued maintenance. The last piece with mobility, when it's in the cloud, we've already touched on this. Anything with an internet-enabled device, you can access your things. When you're on premise, you're usually limited to what's on that network. And I asterisk this as well. So let's say you're hosting a web server where people can, log into a website to learn about what you do for business. If you're hosting this on premise, that website can actually go down if your internet goes out. So all of your customers and your clients can't connect to your servers on premise if you have no internet or no power. Whereas with the cloud, they have multiple layers of redundancy, multiple internet connections to make sure or ensure that your internet connection is stable, you have power, that site stays up. So think of those in those factors as well. To put it into a different example, this is probably one of my favorite illustrations of when people compare on-premise or cloud computing. With an on-premise environment or having things hosted locally, you have a lot more ongoing costs because you don't know what everything that is going on behind the scenes. And then you would pay, they say about 9% of your purchase goes to regular software licensing or maintenance. With cloud computing, you can predict 68% of what your fees are going to be because you see that on your dashboard of how much you're going to pay per month per said server or said service. Whereas your ongoing costs now are simply your subscription fees. The things you won't necessarily know what those fees are with your cloud computing is implementing it, because you do have to have some sort of technical know-how to implement a computer in the cloud. There's some customization or training involved as well. But again, with on-premise, you have a lot more unknowns, such as what kind of hardware to use. Do I need IT personnel to support it? Still have the training and customization aspects too. So some people will actually take cloud computing and split it up across their infrastructure. So they will outsource or put some things into the cloud. And these are just called hybrid cloud models, and I'll explain to that in a few moments. But with a cloud computing model, you see with on-premise, the resource owner is all those things on the far left. So you're in charge of all of that: data, runtime, making sure things are working, storage, networking, etc. You can cloud compute infrastructure. So that would be your servers and hardware. You can also push out just applications and data. So let's say you have a very powerful, intensive app that you're trying to run. Let's say you're running Facebook, but you built your own Facebook. That would be more so of an application with data. So pushing that out to a cloud provider is usually more beneficial because you don't have to manage all these services. And it's really cheap to add more RAM and then decrease the RAM when you're not as heavily used. Or you can do software as a service where you outsource basically everything to the service provider. So when we talked about cloud deployment methodologies, I mentioned hybrid or private clouds. So some people will actually do a mix of all. So there's the cheapest layer, which is called your public or shared or community cloud, where there's a physical server in place with multiple virtual servers on this. And you basically would share the resources of the entire server with their other clients. The downside is that since other customers are using this single server, it may impact your performance of your equipment or your applications or your website. So whenever you see shared hosting or shared services, that basically means you're going to be sharing a box with other clients, and the uptime and availability of that box is dependent on hoping that those other customers on that same box as you aren't going to violate any terms of service to bring that box down. The private cloud is essentially you're getting your own physical server, nobody else is on it, and it's yours. So you know that if people were running things on this box, they're not going to be able to because it's only you. So you're the only one that to blame if you crash your server. There is a higher cost of ownership, however, with private cloud, because again, they're giving you an entire box just for you. And the hybrid cloud is essentially the idea of taking 2 or more cloud models or an on-premise model and split the data into different buckets. So if you had external facing content and you wanted all that in the cloud, but you wanted all your internal company policies, company data, HR files located on a server in your building, that's called a hybrid cloud, meaning you're splitting up the cost of where things are based on importance or needing it consistently available. Most organizations will do the hybrid cloud model because it's the most cost effective. There are a lot of different cloud vendors out there. We're going to talk today, or I'll show you Google Cloud mostly today, but keep in mind there's also the Amazon Web Services, IBM Cloud, Rackspace, and Azure. All very similar offerings, all very similar dashboards. The differences are usually cost or some of the extra feature sets. And I'll talk to that with Google Cloud today. So with cost comparisons, the thing that you want to do when you're trying to figure out what the costs are, they're usually in these main buckets. You have your server running hours, which essentially is how long do you need the server running per day, per week, per month. Most people have servers running 24/7 because they need constant access. However, if you are an 8 to 5 business where your employees do not need to do anything outside the windows of 8 a.m. and 5 p.m., you may change those server running hours and save a little bit of money. Most cloud vendors, though, will actually give you a discount anywhere from 5% to 30% to run your server 24/7. But if you're trying to focus on saving cost, you would choose those server running hours. And then you would then get billed on the resources of that server. And that would be your RAM. How much RAM do you need? How much memory? How much processing power is needed to run apps? So if you're running a website, you don't need a lot of RAM. You don't need a lot of processing power. And then if you want to do a virtual shared or virtual private server, again, the virtual privates are more expensive. Storage costs. So how much hard drive space do you need? A typical website would only need 3 or 4 gigs. And then the software to run it behind that's another 2 or 3 as well. But if you were storing lots of images, videos, and other types of content, you need a bigger storage. What a snapshot is essentially a backup of your running site. So if you take more snapshots, you need more hard drive space. If you had a 10 gig drive and you were using all 10 gigs, you'll need a 10 gig snapshot storage space as well. Archiving and backups, if you want to maintain backups or archives, that's an additional cost because you're paying for space at the end of the day. If you're running databases, some vendors will charge you an additional fee for these databases. And then there's the data transfer cost, which is you get billed per bandwidth usage. Very similar as when we had our old cell phones where you were paid per gig or charged per gig. That idea exists very well in the cloud computing world. So if your website gets a lot of visits and you're planning on hosting a website in the cloud, you'll pay a little bit more for data transfer. If you're running your own Napster or a YouTube or something like that, your data costs will be tremendously larger because you're sending or sharing out larger files. So keep those components in mind. And the other cost comparison that you would have, whether you're on-premise or in the cloud, is licensing. So if you were to run a Microsoft server, you will have to pay a prorated amount for that Microsoft license. If you're running something open source, such as Linux, there is no ongoing license cost to that, so you wouldn't have to pay anything extra. So there's a lot of really nice tools that will compare different servers for you from different providers. The one website that I've used in the past was Cloudorado. And the way it works is when you get to the web page on the left, you would choose how much RAM, storage, processing power, which operating system you need, because again, Windows would you have to pay a fee for because it's a licensed software. How much data you're going to transfer out. So that would be where people would be downloading a file or viewing a website. Or data transfer in, which would be people uploading content to your page. And then subscription is the length of time you'll be running this service, because some providers will give you a discount. I believe Amazon does if you purchase in 3-year blocks. So a very simple server. Google Cloud is the cheapest option, at least when I take the screenshot. There's lots of variants. If you added more RAM, if you added more processing power, these are some of the basic configurations that you can see. There are some dangers and fears when you're talking about clouds computing. Probably my favorite story, and I feel terrible for this person, but someone at Amazon Web Services, there was a systems crash, and this was probably about 4 or 5 years ago now, where someone miskeyed a line of code. An Amazon web engineer that manages all those cloud computers was updating some payment portal for everyone to use, but because of a missed key or an extra character in his line of code, he brought down a large portion of websites. Because Amazon Web Services manages quite a lot of websites out there, which included Slack, Amazon, There was a few other, like Facebook, I believe, used Amazon Web Services at the time. So the entire, I believe it was like East Coast servers. If you're connected to any of those servers on the East Coast, you had no servers. So it brought a lot of businesses down. In total, it was 148,000 websites, 121,000 unique domains. So it was a pretty huge disaster, and things were down for several hours. So that can happen with cloud computing. Maybe not something that severe, but if your vendor is hacked or someone has a misline of code, all of your data, everything like that may not be accessible. The other thing to keep in mind is a lot of vendors will tell you they do backups, but then have a little tiny asterisk that says, but backups are your responsibility to make sure they work. So while they say they're doing their backups and their backup data is lost, they put the onus back on you, saying, well, you should have also done your own program of backups. We're not responsible for that data. So I always tell people, if you have sensitive data, still do your own backups. It's really easy to sync data from a cloud computer to a physical computer or a local computer somewhere, just as a backup method, because you don't want the worst case scenario of your data being disappeared because of a crash or a hack. But there is a lot of really nice opportunities with cloud. The biggest is redundancy and failover. Many of us have power outages, many of us have internet outages, and if you're hosting a server in your environment, that server is no longer accessible. With cloud computing, those vendors have generators, thousands and thousands of dollars worth invested in power redundancy, data redundancy, to make sure when things do go bad, everything still runs with a high uptime. The other cool thing with cloud computing with Amazon, Google, or Azure, they have what's called a server farm, which is a giant building with tons and tons of servers in it, scattered across the world. And the reason for that is if there is a natural disaster, for instance, let's say there was a server farm in Florida that got taken out by a hurricane. Google would have multiple servers everywhere else and would have had that data backed up and synced at a different location for you. Usually you have to pay extra for that type of service, but at least you know you have that redundancy and replication. So in the event something occurs, you can still be up and running. And the other piece with cloud computing is the idea of using it when you need it. So a lot of vendors will give you the ability to see how much. So if you pay for 16 gigs of RAM, but every month you only use a gig, they'll say, hey, you can save money and we can take off 15 gigs of RAM for you per month, and your servers are now even less. Whereas if you were to buy a physical server, you can do that monitoring yourself, but since you've already bought the equipment, it's kind of too late and you own it. Whereas with a cloud computing engine, it's easier to adjust and make those modifications. Some interesting cloud computing stats. They say 84% of IT managers today are currently using some sort of public cloud infrastructure, whether it's partially outsourced or fully outsourced. 84% of them are doing this. They also say, according to Cisco, by 2021, cloud data traffic will represent 95% of total data center traffic in total. So people will be pushing out more content to cloud computing than ever before by 2021. And I imagine this stat is more recent. And I assume that's going to be partly driven by the whole COVID disaster, because people are working remotely, people are trying to do things without being in an office. And so now we're trying to push content or infrastructure into the cloud where anyone can access it, and we don't really have to get someone into a building to recover. Some other cool stats from a recent blog post that also touched on the impact of the pandemic on with cloud computing. They say that more than half of the almost 200 people they interviewed said that cloud usage is going to be greater than expected because of the extra capacity to meet this new demand of, I need to be able to work remotely and I need access to all my content. So why do I like to recommend Google as one of the best, or one of the preferred choice for me for cloud computing? The obvious is you use the same infrastructure and systems that Google uses to deliver Gmail, Google Mail, Google Drive. So they've been doing this for years, and they have a really good network. How many times have you ever went to google.com and the web page didn't load? Or how many times have you went to Gmail and your email never loaded? I will probably tell you never. I think actually one time my Gmail wasn't working. So So out of all that, that's a pretty good uptime for me. So that's why I would use Google Cloud Services. They say that Google has one of the most sophisticated network backbones. And why that's important is you're able to connect to more people around the world. So if you own the highway, think of it this way, Google owns some of the best highways around. So if you had clients, let's say in another part of the country or another part of the world, if they own the best highway, which they have the 9,000 kilometer underwater Trans-Pacific cable, it's this massive fat cable that lies under the ocean that connects Oregon to Japan, was the largest data capacity driver ever built. And so they own that. So your data, if you need to get to Japan, for instance, or the other side of the world, they own the best backbone to do so. It's also slightly cheaper. The solid state drive costs, for whatever reason, are higher for Google than other competitors. Not sure why. And then Amazon has a really nice discount if you do pay for 3 years in advance. But with Google, there's a lot of security and compliance standards that they all meet, like HIPAA, SOX compliance, and more. So when you're thinking of your data, those are some of the security regulations like HIPAA or SOX compliance Google already follows. When we talk to running a server that you want people to access around the world, the way to do that is you want to give it a domain. And the domain name essentially takes an IP address that your server has and gives it real words. The reason why I like Google domains is I get free domain privacy, meaning whenever you buy a domain, you have to put your contact information to this little who is information. It's almost like an address book. So if something's wrong with that domain or you're sending out spam, people know who to contact. However, most people don't like to be called in spam because there's a lot of spammers that look for this information. So Google has created a privacy filter where it's just this generic number and email address. So if people contact it, and again, most of the time it's just telemarketers, they will then only inform you if it's actually worthwhile. But it makes your information private, gives you that extra peace of mind and security. Google has their own pricing calculator, and that's a website. So if you wanted to figure out, hey, I have a server in my building or in my house, I want to know how much it would cost if I was hosting it on the cloud. If you go to that URL, you're able to plug in what your current specs are, and it will spit you out about what it would cost. The cost you probably won't be sure on is the data transmission cost, because there's really no easy way to measure that if you're just running it on your own. So you have to guess. But the amount of data of how they charge is like 0.006 per gig, I think it is. So it's pretty hard to be shocked by that unless you're running, again, like some massive YouTube service with tons of video that people are constantly downloading or streaming. But the Google Cloud Platform can do all of these things. And what all these things basically are is, on the left, servers or apps that you can run content. If you're running massive amounts of storage arrays, that's the storage column. Networking, that would be load balancing, is essentially having two servers share the same amount or share resources so a website doesn't get slowed down. It'll basically copy your website twice and toss people between server A and server B to see the same content. When we're talking about big data, that's the idea of having massive amounts of information and then running calculations on it to make determinations. So if you're running some type of AI engine, big data would probably be something that you would want to play with and look at. But in general, there's a whole bunch of service layers as well that Google offers. So you get access to like Google Translate. So if you needed to build websites to translate from different languages, they have that built in. There are prediction algorithms that you can leverage. So that's the Google Cloud Platform. It's really fun to get started with Google too. So they'll give you $300 worth of credits that you can run for a year. And so the $300, if you don't use it all, it does expire after one whole calendar year. And there's also these always free access servers, which is very, very light servers. So if you wanted to run like a semi-slow WordPress website, you can using Google Cloud for free. And I'll show you how to get that started today. The thing is that you do need a credit card to authenticate your account. They'll only bill you if you run out. And so I'll do a live demo if if everyone wants to, or you can just watch me. So today what I'll show you is the Google Cloud Launcher, how easy it is to basically start a WordPress website. Or if you were into the coding aspect, I can show you how that end looks as well. So let me end my show. And I'm now going to share my browser. Cool. So it's really simple to get started with cloud computing. So if you go to cloud.google.com, we brought to this page. Oops. You're going to see a button. If you're already signed into your Google account, perfect. You'll see a button that says Get Started for free. Simply click on that. Oops. You'll agree to the terms of service after you carefully read it. It's going to ask you to type in what kind of account, individual or business. Then an optional phone number. It's going to ask you to type in a credit card. I have a cool app called Privacy that lets me create a temporary credit card. It's pretty slick. So create free trial. Start my free trial. Did it not take? May take some playing to get it to work correctly, but I already have an account, so I will jump over to that. So when you first set up your account, what you're going to have to do is create a project name, and all that is a container of information that you can then store your websites or servers. So for instance, I have LibChalk Learning Apps, and this is your dashboard. So I'm able to see which servers are running and what peaks of performance they're at. How many servers do I have? So if I wanted to look at said servers, I literally just have to click on it, and it gives me a list of servers that I'm currently running. So 2 of my servers are off, and 1 of my servers are running, which is my WordPress demo. So to get started, the fastest and easiest way is using their marketplace. So if I click on the hamburger menu, I believe some people call it, and click Marketplace, I'll be brought to a list of apps. So these are all things that you don't have to actually program and do. Somebody else Google has already done the legwork of setting up everything onto a server box, and you literally just have to click and go. So to explain, if I wanted a WordPress website, the hard way would be spinning up a server, downloading code, telling the code to run, creating an account, creating a database, loading content into the database, and then finally, I'll be able to have a WordPress website. If I wanted to launch WordPress, it even gives me an estimated cost per month based off of these stats. And again, that's like overkill for a WordPress site. So I'll click Launch. What it's going to do, it's going to ask me to come up with a server name. What zone do I want it in? And so geographically speaking, where would I like this server to be? They say to choose your zone based on where most of your clients are. Because in theory, it's quicker to get to, and we're talking milliseconds, but it's quick. Those end users are going to get to your server quicker if you choose a location closest to them. It's going to ask you to type in an administrator email account. Well, this account will be used to sign into your WordPress website. This is your boot disk. How big do you need the space to be? And then here is where you do your machine type. I'll tell you, you can get away with using a micro box. It's super simple. Now I'm only at $4.83 per month. And I'm going to then basically click deploy. So again, behind the scenes, what's happening now is Google's running all these scripts, so you don't have to program a website to create WordPress. So it's currently building a server for me. It's installing WordPress, and now it's even going to give me, it's going to set up my databases. It's setting up my WordPress account, which is here. And in a few moments, I'll get a URL that everyone can access right now in the world. It's not always instant, but this is a lot faster than you going to a store, picking up a server, mounting it into your server rack, plugging it in. You'll also have to configure your network to say, hey, this server is accessible from outside of the world, and then as well as installing all the software you need. The software needed to run WordPress is Linux, MySQL, Apache, which is a service that allows you to run a website. So now, if everyone wanted to go to this address, I'll post it in chat. That's a real working website that we just created today. If I wanted to log in, what's the password? So now I'll sign in. My new password. Oops. To show you it's not smoke and mirrors, I will post an update. So right now, this is what the website shows. We'll edit this post really fast. The world, thank you for joining a DoSpace webinar. Update. So now we have our updated post here. So in seconds, maybe a couple minutes, we've then built our first WordPress web page without having to know any coding, anything fancy. We just literally clicked on a couple buttons. And that's how easy it is to get started with Google Cloud Computing. For people that are a little bit more advanced and want to see how to do the pieces one by one, if you go to Google, when you go to your Google Cloud platform, we're going to go to Compute Engine and go to VM instances. Here's your list of servers. To create another server, all we do is we hit Create Instance. We're going to call this DoSpace. I'm going to choose a location, choose what kind of server type. It's going to ask me what type of operating system I want. You're better off using Linux or Ubuntu. Click Select. So what I've done was I chose the operating system I wanted to run. If you wanted a different operating system, the ones that you have to pay an extra license for, it would be Windows. The other ones here are free. If you're making a server host a website, you'll want to check allow traffic for HTTP and HTTPS. If you don't, the Google Cloud doesn't know that people from outside the world want to connect to it, and you won't be able to connect to it, obviously. So these are just firewall rules. Instead of running a line of code, you just check boxes, and it will do that coding for you. And hit create. Again, it takes a little bit to create a server space because it's doing this live. And now I have my server. If you go to this address, it ain't going to work yet because that server is not running anything that a website can load. Basically what it's not running, it's a service called Apache, and there's nothing behind it to tell it to run. So we're gonna do some coding. To talk to a virtual machine or talk to a cloud computer, you necessarily don't have a window. You don't see like a start bar or a menu. What you do have is what's called SSH. Make sure you see my other screen here. Cool. So now you should hopefully see a black screen with white text. What I'm going to do is I'm going to send commands to my server. So in order to make a server into a web server, you have to install what's called Apache. So the command line is sudo, which is telling your server to run in as a super user. Apt-get means to check a repository, almost like how you would go to a Google Play Store or an Apple Store to download files or programs. We're telling you to install something, and we're telling you to install Apache. So now it's downloading the necessary packages and hopefully installing. Come on. There it goes. So now that Apache is installed, our server can now have an interface for the world to see. But there's nothing for the world to see yet until I create a website. So what I need to tell it to do is go into a very specific folder for creating websites, which is this folder here. And, so I'm basically telling it to create a file and move the file, index.html. Oops. And so now what I'm going to do is edit this file. So now I'm editing a file on my server. So again, doing everything through command line is a little challenging if you've never done anything like this before. But there's tons of instructions online to follow, and it'll walk you through this very similar process. I've also included in my PowerPoint slide the command lines I've been using so far today, so you can see it live or do it live yourself. So if you've never created a old-fashioned website, this is how you do it by hand for those that are interested. Hello, do space. Oops. So now what I'm doing is I'm creating the website. So body, oops. Hello world, welcome to do space. I'm going to save the file. So now I've created a file that's accessible to the world. The last thing I'll need to do is tell Google that this server is accessible outside the world. It has this external IP address, but it doesn't load anything, as you've noticed. So what I have to now do is the last piece of our puzzle. It's called our networking engine. So we have to go to network. Where is it? We want to add an external IP address to it. So allowing people from outside the world to connect. So all I have to do is go to our do space one, change this to static. Do space IP. So now I've basically created that IP address that I had earlier, and it allow people to connect to it. So did it right. And you do have to pay extra for a static IP address. And again, it's a minimal fee. So I'm going to go back to my virtual machines. Should have worked. Oh, you might not have been able to see me add that IP address. Stop share. It's one of the downsides of, oops, wrong one. There we go. Of sharing apps. So what I did was inside of Google Cloud Compute Platform, I scrolled down where it says VPC network, and I chose external IP addresses. I clicked on the server I created, which I've already done. So we'll pretend this is it. And you change it to static. And what that does is essentially says, hey, this address shouldn't change, and it's accessible to the outside world. So now what I have to do is give me 1 second here. I think I missed a step. All right. The world might not know that the site exists just quite yet, so give it a little bit. Try again in a moment. But that essentially is Google Cloud Computing, how we can build a website through a few clicks, or if you were wanted to geek out, I'll share my PowerPoint with you again. If you wanted to geek out, here's the lines of code you'll have to use. Share. So those are the steps to do those things. Are there any questions? Did this make sense? Was this eye-opening? Do you feel confident in using it? Let me pull up the chat. And again, if you wanted to reach out and you had questions, whether you're watching the recording or watching live, here is my contact information. Basically, hopefully what you got out of it today is that it's not really that scary to put a server together in the cloud, especially if you're going to leverage Google Cloud's marketplace, because again, it's just a click to install WordPress and it does all the other magic for you. And here's the server we made by hand today as well. And again, we did this all through just a few lines of code, and those lines of code was the slide. Are there any questions? Does this all make sense? All right. Well, there's nothing else. Thank you for spending your Tuesday evening with me as we talked about Google Cloud Computing. Feel free to reach out if you do have any questions or comments or concerns. Be happy to show anything else. If you have any questions, feel free to ask in the chat box. All right. Well, I'm not seeing anything, so thank you for joining, everyone, and enjoy the rest of your day.